Hello everyone and welcome back to our favorite place to be, UE4. Unlike what I mentioned at the end of the last video, today we'll be covering a fix for our system that I actually overlooked. This fix will enable the full power of the stackable traits for items. I apologize for missing this the first time around. Before we get started, if you want to connect with me, feel free to follow me on Twitter, and subscribe to the channel for more randomly educational content. Alright, let's hop in. I've taken the opportunity to build up a little scene so we can enjoy some real aesthetics while we're whipping together some features. I am using the Advanced Village pack from the Unreal Marketplace for this scene. Link to it is in the details of this video. The bug in question is when you add multiple of a non-stackable item to the inventory system. Normally, this just adds a stack to an available slot or to an existing slot. However, for non-stackables, this creates a stack of non-stackables, instead of filling the inventory with each item in the stack individually. Now obviously this is a travesty of the highest order, so to fix this we're going to change how the detection works for empty slots. When we go to add non-stackables, we'll first check whether there are enough empty slots in total in the inventory system. If there are, then it will add each item to an empty slot. If there are not enough in total, the entire operation will be cancelled. Let's jump into this. In your content browser, open up the libraries folder and open up bpfl_inventory. The first thing we need is a new function that helps us understand how many empty slots exist in total. Add a new function and call it getEmptySlots. This function has one output variable called empty_slots of the type wg_inventory_slot. Now this is also an array variable. You also need a local variable called foundEmptySlots of the type wg_inventory_slot. This is also an array variable. This will be used to cache our increasing total of found empty slots before ultimately returning them all. With that added, let's review this code. We start by grabbing a reference to our inventory itself, and then accessing our inventory slot array. We hook this up to a loop, and for each slot in our array, we check whether it is empty using the name property of the information struct. If it is, we add the reference to our reference array. Once all slots have been checked, we return the array of found slots. Because this function doesn't actually manipulate data though, and simply just collects it, this makes it a perfect candidate for being made a pure function. In the details panel, make sure to check the pure checkbox. With that, let's move on. Open our add item function. To support this new change of functionality, this function requires a significant rework. I recommend disabling and moving the existing code and beginning from scratch so we can properly understand each change individually. The first change we need to make is adding a new local variable called empty_slots of the type wg_inventory_slot. Make sure this is an array variable. With that, let's walk through our newly upgraded add item function. We start like we did before by caching our inputs so we can avoid mom spaghetti. We then confirm whether the item to add is stackable. This is the big split between our code for adding stackables and non-stackables. Let's cover stackables first so we can get a clear picture of the difference. If the item is stackable, we start by scanning for whether this item already exists in the inventory system. If it does, we grab a reference to which slot actually holds that item, and we update the quantity of that slot to reflect the quantity we wish to add. Then we simply return a success for this function. Stepping back though, if the item is ultimately not found at all, we scan through the inventory system for the first instance of an empty slot. If one is ultimately found, we grab a reference to that slot and set its information to reflect the item we're passing in. This supports any number of quantity, so if we're adding something like 15 animal crackers, the system has our back and will add a stack of 15. After that, it updates the UI to reflect the change and returns a success. However, if no empty slot is found, this means our inventory is full. We return that the addition has failed. This is the full tree for stackable items. Let's jump all the way back and review the non-stackable tree. If the item is not stackable, we need to check whether we have enough empty slots in total to account for the quantity of the item we wish to add. In this case, we use our new getEmptySlots function to populate our empty slots array variable. Then, we check whether we have the prerequisite number of slots available. If there aren't enough, we return a failure. If there are though, we then move on to actually adding the items one by one. We use a for loop which uses the quantity to add input variable as the total number of iterations. Then we use the iterator as the index for our empty slots array. This returns an available slot each time the loop iterates. Using this slot reference, we set its information to be that of the item we wish to add. After that, we do something particularly different from the stackable item add. Instead of using the quantity to add input variable as, well, the quantity to add, we simply add only one. This is because we're using the quantity to add variable as the number of slots to take up, instead of the stack size of a single slot. After we do this, we simply refresh the UI and continue on. Once all slots have been appropriately filled, we return a success. With all that in place, our newly improved add item function is done. Let's step back and adjust some things so we can test this new functionality. Last time, we set up some testing code that lets us add some items to our inventory. We want a use case where we can add multiple non-stackable items to our inventory to see if our code actually works. However, all of the items we've added are marked as stackable currently. Let's fix that. Navigate to your data tables folder and open up your dt_items file. Inside, let's change our great pumpkin item to have false for the stackable column. With that done, close this file, locate your player blueprint, and open it up. Where we put the testing code last time, specifically for adding our great pumpkin item, let's change the quantity to add value to 5. With that, let's actually test our code. Press the play button. In my case, I'll press the R key to add 5 great pumpkins to my inventory. Now we'll see that the 5 are added individually, taking up their own empty slots. If I keep pressing R, it'll eventually stop when there are no longer at least 5 available slots left. We now have a simple, functional stack system. And that's it. Thank you once again for joining me. If you liked this video or found it useful, please make sure to hit that like button and subscribe if you'd like to see more. If you'd like to get in touch or hear my daily development rants, follow me on Twitter. Most importantly though, leave your thoughts and ideas in the comment section below, as I'd love to hear them. As always, I'll see y'all in the next one.